Venus is not the hottest planet because it's closest to the sun. It isn't. Mercury is closer. Venus is the hottest planet because it did something Mercury couldn't. It built a trap. A 96.5% carbon dioxide atmosphere, 60 miles thick, wrapped in clouds of sulfuric acid, the most aggressive greenhouse effect in the solar system. Sunlight gets in, heat doesn't get out. The surface bakes at 867 degrees Fahrenheit, hot enough to melt lead, zinc, and your confidence that any planet named after the goddess of love should be this hostile. Venus is the same size as Earth. Same mass, roughly, same rocky composition, same neighborhood. Scientists used to call it Earth's twin. They were wrong. It's Earth's evil twin, the version of our planet where everything that could go wrong did go wrong all at once, and then kept getting worse for 4 billion years. And today, Max is going to try to land on it. Try being the important word in that sentence. The first thing you'd notice about Venus isn't the heat, it's the sky. Venus is permanently overcast. Not the way London is overcast. The way a nightmare is overcast. The cloud layer starts at about 30 miles up and extends to 45 miles. It's made of sulfuric acid droplets, not water. Acid. These clouds are so thick and so reflective that they bounce about 75% of all sunlight back into space. Venus actually absorbs less solar energy than Earth does, and it's still hotter. That's how insane the greenhouse effect is. Venus is reflecting most of the sun's energy away, and the small fraction that gets through is enough to maintain surface temperatures that could run a pizza oven non-stop for 4 billion years. From the surface, the sky would be a dim orange-yellow haze. No blue, no stars at night. The clouds are too thick, no shadows with sharp edges. The light is so scattered and diffused that everything has a flat, sickly glow. You'd never see the sun directly. You just know it was up there somewhere, like a lamp behind 17 curtains. Max looks up through the cockpit window on descent. Orange murk in every direction. No horizon line, no ground visible yet. Just soup, thick, toxic, glowing soup. This is fine, he says, in the exact tone of voice that means this is not fine. Somewhere in the back, Cosmo is chewing on a seatbelt strap, completely unbothered by the fact that it's raining sulfuric acid outside. The pressure on Venus's surface is 93 times Earth's atmospheric pressure. 93. That's equivalent to being 3,000 feet underwater. A submarine would be crushed. A car would be flattened like a soda can. Every square inch of your body would bear 1,350 pounds of force. The Soviet Union actually landed probes on Venus multiple times. The Venera program from the late 1960s through the 1980s dropped a series of increasingly armored landers onto the surface. The first ones were destroyed during descent, crushed before they even reached the ground. Later models were built like deep-sea diving bells, reinforced to withstand pressures that would kill anything biological. Venera 13 holds the record. It landed on March 1st, 1982, and survived for 127 minutes. 2 hours and 7 minutes on the surface of Venus. That was the best humanity has ever done. The photos it sent back, orange-tinted, low resolution, showing flat rocks and a barren landscape, are still some of the most haunting images in space exploration. Another world, completely, violently alien, and we only got to look for 2 hours before Venus ate the camera. Max brings the ship in low. The hull groans, not dramatically, just a creak like a house settling, except the house is being slowly compressed by an atmosphere the weight of an ocean. Hull integrity? He asks out loud. The ship's instruments show green. For now, Cosmo has stopped chewing the seatbelt. His ears are flat. cat. He can hear the groaning, too. Dogs don't understand atmospheric pressure, but they understand when metal shouldn't be making that sound. Here's something that messes with your sense of direction. The sun rises in the west on Venus. Venus rotates backward. Every other planet in the solar system, except Uranus, which has its own problems, spins counterclockwise when viewed from above the North Pole. Venus spins clockwise. Retrograde rotation. Nobody knows exactly why, but the leading theory is that something massive hit Venus early in its history and either flipped it upside down or reversed its spin entirely. And that spin is absurdly slow. One full rotation takes 243 Earth days. That's longer than a Venus year, which is only 225 Earth days. So a day on Venus is longer than its year. The planet completes a full orbit around the sun before it finishes a single rotation. It's like a runner who circles the track faster than they can turn their own head. If you stood on the surface and waited for sunrise to sunset, one full solar day, it would take 117 Earth days. Almost 4 months of daylight, followed by almost 4 months of darkness. Although daylight on Venus means slightly brighter orange gloom, and darkness means slightly darker orange gloom. The temperature doesn't change between day and night, not even a little. 867 degrees Fahrenheit around the clock. The atmosphere is so dense and so efficient at distributing heat that there's essentially zero temperature difference between the equator and the poles, between noon and midnight, between anywhere and anywhere else. Venus has one temperature, everywhere, always. It's the thermal equivalent of a pressure cooker with the dial broken off. The surface itself is volcanic, massively, aggressively volcanic. Venus has more volcanoes than any other planet in the solar system, over 1,600 major ones that we've mapped, and potentially tens of thousands more. The largest, Matmans, rises about 5 miles above the surrounding terrain, and some of them might still be active. In 2023, scientists reanalyzing Magellan radar data from the early 90s found a volcanic vent that had changed shape between two orbits. Strong evidence of an eruption happening in real time, or at least within the few-month window between measurements. Venus Express also detected spikes in sulfur dioxide in the atmosphere, consistent with volcanic outgassing. The planet's entire surface appears to be relatively young, around 500 million years old, give or take. That might sound ancient, but for a planet that's 4.5 billion years old, it means something catastrophic happened recently. The leading theory is a global resurfacing event, a period where massive volcanic activity essentially repaved the entire planet. Every crater, every feature older than 500 million years was buried under fresh lava. Imagine redecorating your house by filling every room with concrete and starting over. That's what Venus did to itself across the entire planet. Max lands the ship, or more accurately, the ship arrives at the surface through a controlled descent that felt nothing like control. The ground outside is flat, dark basalt, orange light. No wind at the surface. The atmosphere is so dense down here that air moves at walking speed, but it hits like a truck because the gas is almost as thick as water. Max looks at the external temperature display, 867 degrees Fahrenheit. Pressure, 93 bars. Atmospheric composition, 96.5%. CO2, 3.5% nitrogen, trace sulfuric acid. So basically, an oven inside a pressure cooker inside an acid bath. Cosmo is sitting at the airlock door, tail wagging, waiting to go outside. He does this on every planet. He has never once been allowed outside. He will never stop trying. Max respects the persistence. Max does not open the door. The wildest thing about Venus isn't how hostile it is now. It's how hospitable it might have been. Climate models from NASA's Goddard Institute altitude suggests that Venus may have had liquid water oceans for up to 2 billion years. Actual oceans, potentially habitable surface conditions, moderate temperatures, maybe even life. Then something changed. Possibly a massive volcanic episode pumped enough CO2 into the atmosphere to trigger a runaway greenhouse effect. The oceans began to evaporate. Water vapor, itself a greenhouse gas, trapped more heat, which evaporated more water, which trapped more heat. A feedback loop with no off switch. Over millions of years, the oceans boiled away entirely. The water molecules drifted into the upper atmosphere where ultraviolet radiation split them apart. The hydrogen escaped into space. The oxygen reacted with surface rocks. Gone. Permanently. Venus didn't start as hell, it became hell. Slowly, irreversibly, through a process that started with too much CO2 and ended with the complete loss of every drop of water on the planet. And here's why that matters beyond Venus. The same greenhouse physics that turned Venus into a furnace operates on Earth. The same molecule, carbon dioxide, is the primary driver. Earth's oceans, Earth's magnetic field, and Earth's distance from the sun have kept us on the safe side of the tipping point. So far, Venus isn't just a cautionary tale, it's a preview of what runaway warming actually looks like when there's no mechanism left to stop it. But there's one more thing. One weird, almost hopeful detail buried in all this horror. 30 miles above the surface of Venus, things get surprisingly pleasant. The temperature at that altitude ranges from about 86 degrees Fahrenheit to 158 degrees Fahrenheit. The pressure is roughly equal to Earth's surface pressure. The radiation levels are manageable, and the atmospheric chemistry, while still acidic, is survivable with the right equipment. Some scientists, and they're not fringe scientists, these are NASA and ESA researchers, have proposed that microbial life could exist in Venus's upper cloud layer. Dark streaks in the clouds absorb ultraviolet radiation in patterns that nobody has been able to fully explain with known chemistry. The composition doesn't match any purely mineral explanation. It might be nothing. It might be iron chloride, but it also might be something alive. In 2020, researchers announced the detection of phosphine gas in Venus's clouds, a molecule that, on Earth, is only produced by biological processes or industrial chemistry. The finding was controversial. Follow-up studies disputed the detection. Other studies supported it with additional data. As of now, it's unresolved. But think about what that means. The most hostile planet in our neighborhood, surface hot enough to melt lead, pressure that crushes spacecraft in hours, raining acid from permanent clouds, might have life floating in its sky, not on the ground, in the clouds, exactly where Venus is least like Venus and most like Earth. Max pulls the ship back up through the cloud layer. The hull stops groaning. The temperature drops. The pressure eases. Through the upper clouds, filtered through sulfuric acid haze, the sun becomes faintly visible for the first time. Dim, but there. You know what's crazy, Cosmo? The worst planet in the solar system might have life. Not on the surface. In the clouds. Floating. Just vibing up here in the acid rain like it's no big deal. Cosmo is looking out the window at the clouds. His nose is pressed against the glass. He can't see anything alive out there, but he's looking anyway. Dogs do that. They look for things before they know what they're looking for. Venus is Earth's twin the way a mirror is a portrait. Same ingredients. Same starting point. Completely opposite outcome. One planet got oceans and a magnetic field and a nitrogen-oxygen atmosphere and eventually golden retrievers. The other got sulfuric acid rain and a surface that destroys spacecraft in 2 hours. Same recipe, different oven. The difference between paradise and hell in planetary terms isn't that large. A little more CO2, a little less magnetic field, a little closer to the sun. Small changes compounded over billions of years until one twin is covered in water and the other is covered in regret. Max sets the ship on autopilot heading away from Venus. The planet shrinks in the rear viewport. Brilliant white, beautiful beautiful from a distance, permanent clouds hiding everything terrible underneath. She's pretty from up here, Max says. Cosmo is already asleep in the co-pilot seat. He doesn't care about Venus anymore. Venus is behind them. The next planet is ahead, and wherever they go next, Cosmo will try to open the airlock door, and Max will say no, and Cosmo will try again next time. It's their thing. Next time, Max and Cosmo are heading to the one planet humans actually talk about moving to, a planet with the tallest mountain in the solar system, a canyon that would stretch across the entire United States, and a sunset that's blue. Mars, the planet that's tricking everyone into thinking it's habitable.